Hello, good morning all.
Yeah, hello, good morning, all. So I guess our group one is present, so we can get started with the first one with group one.
So Nitish, will Professor be joining as well before we get started?
I guess Ayushi, our eMasters team head, is here, so we can get started.
All right, sure. I think we have one team member missing, Saurav. Javed
Yeah,
should be.
Saurabh is still to come, so we can wait for him for 1 or 2 more minutes.
Meanwhile, are we allowed? Do we have a permission to share our screen? Honey, did you check?
I guess it is allowed.
Yeah, it works during classes, so I'm sure.
Okay, okay, perfect.
I guess screen sharing is allowed for each one of the member, I guess.
Sure. Javed, would you like to ping Saurav, Javed, or Rajni?
Rajni is online. That's
Yeah, good morning. I am here, Rajni.
Yeah. Can
Hi,
we ping
Rajni.
Saurav?
Hi, good morning.
Okay, let me try.
Yeah, Saurav is now here, I guess.
Yes, Saurav is here.
Okay, he's here now.
All right, let's get started. Hello and good morning, everyone. Welcome to the presentation on Smart Home Energy Management System. Today, we are going to walk through the report and the demo as prepared by Group 1. This group comprises of Javed, Rajni, Saurav, and me, Honey. We are going to give you a quick round trip of the entire report, and then we'll also walk through the demo. But before we delve into the report, I would definitely want to acknowledge Professor Priyanka for sharing her insights throughout the lectures, and then TA Nitish for helping us with quick responses to the queries that we had, and the platform wokwi, which helped us simulate the entire content. Last but not the least, I would also want to acknowledge my colleagues, my teammates, Javed, Rajni, and Saurav for the complete support throughout, and then for also coming up with the entire coding, entire deliverable in the stipulated time frame. So starting with task 1, the problem statement was a use case wherein Sita wanted to have a smart home management system. This smart home management system should adjust heating, controlling, and lighting based on the occupancy and environmental conditions. And it should also ensure that there's efficient usage of energy throughout. So the goals were to ensure that there was a simulator which could, with sensors, which would simulate all sorts of motion, temperature changes, or distance changes as a person moves around the room. And then the LEDs should go on, should glow, or they should turn off as per the motion. Then we were also supposed to display the readings from all sensors on the LCD. So the functionality is similar to the use case that we have. We would have temperature monitors because we have a sensor in place that is going to monitor the temperature. There's going to be motion detection by sensors again, and I'm going to walk through all sorts of sensors that we have used while I discussed about the components. Then there's going to be distance measured as per the threshold. Within and outside a particular threshold, the LED should glow or it should turn off. So these are the specifications which were shared with us, and based on these, we have used the components and we have assembled the circuit. The first one is the Arduino board, which helps us for the entire simulation. Then we have the NTC temperature sensor, which is the negative temperature coefficient sensor, which allows us to sense temperature and then passes on the required voltage for the LED to glow or for it to turn off. We have PIR motion sensor, we have ultrasonic distance sensor, we have the LCD display and LEDs, 3 LEDs for each sensor, and then we have the OLED display. So this is how the circuit diagram looks like, and I think during the demo and the simulation, this would make more sense, but a very high level overview. We have the Arduino board, and then we have our temperature sensor here. We have the ultrasonic distance sensor, all of the PIR motion sensor, the LCD, which will tell you whether the temperature is whatever the temperature value is, and whether the heating is on or off, whether the motion is detected or not, and what is the distance of the person. And also we have an OLED screen, which would give you details about the group and the people who are involved in the project. We have three LEDs which would glow and which would turn on and off based on the values, threshold values defined on the code. Now, the most important part of the entire logic and the code flow now follows. We have, and I think while doing the demo, we will also give you a quick walkthrough of the code as well, but just to give a very high level overview. We have the implementation, we have included these libraries, which is the liquid crystal for the Heatmap for managing the functions of the LCD. And we have also included U8 2G lib so as to manage our OLED device that we have on the board. We have initialized the displays so that it mentions about the group name and the people who are involved on the project, as we discussed earlier. So all the parameters and all that you see here are used to define the same. This is how the OLED screen looks like when you zoom in. So it talks about the group and the people. Then we have defined all the constants and variables wherein each pin tells you, each pin value will define where the pin is collected and what are the current values that are the initialized. After defining all these constants and all, we have defined a custom character for, say, cooling or heating. So this is done because, going by the name Sita, we have considered that Sita belongs to India, and India is a tropical country where, of course, the temperatures are variating between high and low. So if the temperature is too high, of course, we would want the cooling system to turn on, while if the temperature goes down, we would want the heating system to turn on. That's why we have defined these images so that the person gets to know what function is happening, just like we have in regular room where we have in hotels or offices. So if you see here, while heating, a flame icon will come, and while cooling, a snowflake icon would come. Then this function is to initialize the Arduino board so that as and when it starts, all the pins get initialized, the hardware, the variables, everything gets initialized. This piece of code will take care of that part. I'm not going into details of these. Then we have
It is completely fine because we can skip these the code part, so it's okay.
Okay, so maybe I just wanted to talk about the thresholds and all quickly because we just wanted to make you aware as to what thresholds we have used. As I said, for the temperature sensor, this is a negative temperature coefficient sensor, and with the change in temperatures, the resistance goes down. I mean, if the temperature goes up, the resistance goes down. So based on that, we have defined a threshold of, say, 24. Within the range 21 to 24, the LED would be off. But say if the temperature rises above 24, we would want the cooling to be turned on and the LED would glow. Similarly, if the temperature goes below 21, the heating would turn on and the LED would again glow. Between 21 to 24, there would be no light on the LED. So that's how it would look like. We will go through it during the demo as well. The PIR sensor, as we know, it detects the motion. It has 5 seconds of delay to ensure that there are no false triggers, and we have also a 1.2 seconds delay. So this piece of code will take care of that. And finally, we have, so this is how the LED would glow if motion is detected, and it would turn off when the motion is not there. We have the ultrasonic distance sensor as well, and this sensor emits pulse waves of different lengths, and then based on the time taken and based on the speed of light, the formula that we typically use is distance is equal to time into speed, and based on this calculation, it would change the values of the voltage, and therefore our LED will glow or it will turn off. So for now, we have defined a threshold of 5 to 12. Within a range of 5 to 12, our LED would turn on, otherwise it would turn off. So that's the details about, and this is how it would look like. We would go through it during the simulation, and then we have cleared off the LCDs and the LEDs. These are the use cases that we will walk through during the demo. The first one about temperature, the second one about motion, and then about distance. Component specification we already covered, and then finally task 2, wherein our problem statement was having problem statement involved having a use case where a complete data set with different temperature and humidity values across different dates and different times were shared, and we had to classify that data based on the thresholds that were given in the problem. So the deliverable has been shared in the form of the IPYNB file, and then we have used different sorts of libraries to analyze the data and to present it. This is how the data frame would look like. We have also included various sorts of validations on the inputs for temperature, humidity, and date time to ensure that they are in the expected format. And finally, when we classify everything, all the dates as per their relevant classification, cold or cold and dry, hot or hot and humid, we are able to plot this across times. So this is a complete graph across years as to how the temperature changes throughout the year, how the humidity changes throughout the year. And we also have a calendar heat map wherein across years, across months, across dates, in fact, how does the temperature and humidity values look like? So based on the classification that we have obtained above, we have been able to define this across years. So if you see these heat maps are till 2020. So that's on the presentation side, and again, iterating on the credits part. Maybe I'll hand it over to Javed now for doing the simulation. Thank you.
Thank you so much, Shani, for walking through us through the report. So allow me to share my screen. I hope it's visible.
Yes.
Okay, so this is the project simulation project which we have created as a team. We name it as a SHE-MS, smart home energy management system. And she already presented all the component, all the sensor we have used in this project. So let me run this simulation. So when first LCD, we are showing the group and then the default setting everything. Right now it's showing the temperature at 23 degrees Celsius, then motion. There is no motion over here. So it's saying that there is no motion over here. The distance is 402 centimeter. By default, it's 400, but it's showing 402. I will explain that why I'm seeing the difference over here also. So let's start with the temperature. As he mentioned during the presentation of the reports, that it is negative temperature coefficient. Actually, as the temperature will increase, the resistance will decrease. That's how the fluctuation of the resistance, it will measure the temperature over here. So right now on the top, it's like 23 degrees Celsius. Same, we are seeing the temperature on the LCD screen. And as we mentioned, that we have chosen the threshold of 25 degree, upper limit is 25 degrees Celsius. So as soon as the temperature of Sita's house will go above 24 degrees Celsius, the cooling will be on. So let's try that. So what I'm going to do that, I will increase the temperature. As I increase the temperature, we can see that over here, the cooling has started over here. So we can see the cooling is on, and as well as we see the visual presentation over here also. So the cooling is flat symbol is over here also. Let's try with our cooling off period. So the cooling off period, which we called is the comfort zone kind of things, which is 21 degree to 24 degrees Celsius. So it seems it's indicating that neither your cooling or heating is working. So it means your electricity bill is not running. So you're less burden on your pocket and something like that. So now let's try with the going less than 21 degrees Celsius. As soon as we'll decrease the 21 degrees Celsius, our heating will start on, which we can see on the LCD screen. So this is how the Sitas will come to know that's whether my heating or cooling is switched on, which one is switched on or not, whether either of them was working or not at the time. So this is related to the temperature over here. Now moving to our the PR motion sensor, which will take the motion using the infrared IR radiation, infrared radiation. As we know, that's all living objects having temperature, which is varied based on their temperature, is emitting the AR radiation. That's how the PIR sensor knows by using the pyroelectric material through which it knows that there is a variation of the AIR of the object within their range. And let's try with the simulation. As soon as we click on the PR motion, we'll see there is the motion detector. It means there is an object on their view. So an LED will glow over here, which will show that's the okay, the motion has been detected. And after that threshold time, it will go off again. The motion is, there is no any motion or anything. Now moving to third component, which was our related to our distance over here, which is ultrasonic distance, which is, as he mentioned, that's we are using the pulse. So pulse will go to the object using the ultrasonic wave. And then the true and false, it means two. It means it will go and then it will come back. So how much time it will take the pulse to hit the object and then come back? Based on that, we are doing the calculation over here. Let's see, it's showing the 400, the default value on the simulation, and we see on the LCD screen, we see the distance as a 402 centimeter and showing as a centimeter over here. Let's try to decrease the temperature. Now we are 366 centimeter. Now we are seeing the 368 centimeter over here. So as we are running this simulation, we are changing the distance. We see the same value it's coming on the LCD screen as per the specification specified for the assignment. Now, why I'm seeing the variation? That's we have 366 on the simulation, but on the LCD is coming 368. To coming to the implementation part where we are doing the calculation, this is the factor which is playing a role over here. Because the duration, the ultrasonic pulse, it will go back and it will come back. So we are dividing by 2 because it goes there and then it come back. And then we are multiplying with the speed of the sound, which is 0.0344. So, but as per, if I look into the simulation of the sensor, it is telling divide by 58, which is the exact value. But in our case, it is coming at the 58.13 as per the real calculation over here. That's why we are seeing the variation over here. So this was our simulation part over here, which is with all the component, with all the specification and everything. Now coming to moving to our next task 2, which is related to the classification of the temperature and the humidity, which was the data sheet was given to us. Based on that, we have to do the classification. Everything it's completely coded into the Python code using the Jupyter. So first we read the data and everything, then we are showing over here the data, whatever the data we have from the data sheet. Then we are checking all the whether we have a correct format or not, to make sure that's we are getting. It might possible that's the IoT device is the coded in the wrong way and we are getting the wrong data and everything. But to make sure that we have a correct data, we are validating that. Even though even along with the temperature, we are validating our temperature, humidity in correct format or not. Then we are segregating, we are averaging all the temperature and everything. We are classifying the data which we have in the sheet based on the if temperature is greater than 30 or the humidity is less than or equal to 70, then hot and humidity, which is already mentioned in the assignment. Based on that, we have to do that.
Sorry for interrupting, Javed. So can we go directly to the visualization part?
Yes, this is the one airwise he already showed in the report, but this is the part we have draw the graph based on the value which we have defined based on the classification. And then we are doing another graph based on the heat map for the month and date wise we are doing it. This is related to the task 2. Sorry, we are taking time because this is the first time, we are first batch, so we don't know how that's going to try. So I will hand it over to our team member, Rajni and Saurabh, if they want to share something from their side of their experience, anything. So within a few seconds or minutes, they are free to share that experience or their feedback and everything. If they have comments or anything, their experience.
Yeah. Hi, Javed. Thank you. So Nitish, in this presentation, we have explored the development of smart home simulation using Arduino and various sensors. We have discussed the challenges and the successes encountered during this project, as well as the valuable lesson learned. So, and the simulation successfully demonstrated the potential of IoT technology to enhance home comfort, efficiency, and the security. By integrating the temperature, motion, and distance sensors, we are able to create a realistic environment for monitoring and prediction. So, in addition, we analyzed data set of temperature and humidity values to categorize days based on the predefined criteria. This analysis provided valuable insights into the weather patterns and their impact on the environment. So we believe this project represents just a glimpse of the vast potential of the IoT technology, from smart cities to personalized healthcare, and the possibilities are endless. So as we like to explore new application and advancement in the IoT technology that will continue to shape our world. And thank you again for your time and attention.
Thank you, Saurabh.
Yeah, I am Rajni. And thanks team for this teamwork. And I have learned a lot during this project session. And the goal to monitor and manage the environment parameter like temperature and distance using the sensor was a great experience. And we worked on a real-time issue happening nowadays. Energy efficiency is the most important factor nowadays. And controlling everything automatically in the home system was a great project given by the eMaster team. Thank you. Thanks.
At the end, thank you, Rajni. Thank you, Saurabh. Thank you, Hani. At the end, I would like to thank Nitish, which Hani already mentioned in the draft, but I would like to thank Nitish again because during the when we are doing the demo in our team, we came up with a few questions and then we decided to shoot the question to you, and you timely replied to that question and we clarify all our doubts and everything. So thank you so much, Nitish.
Thank you, Hani, Javed, Rajni, and Saurabh for the great presentation. So I had just one question. So do you guys applied some other visualization plots like in a rough way and later on come to the final plot that you used like a calendar plot, or was it the final plot that you used?
No, we actually, I think Javed can also explain this, but just to start with, we did use lots of pie charts and then bar charts to see which one is looking better. And finally, because this is a data that we had to give across years and across months and across date, we identified the calendar heat map as the best suited item because that is giving us the granularity of detail that we need. So we did try across with lots of combinations.
Yes, I remember
Okay,
that.
so even
Yeah.
yeah, go ahead, Javed.
Sorry, Nitish. I remember that me and Hani was online and we are discussing how to present these things. And I was trying and Hani was giving the feedback. Okay, this looks good, nice. Now let's try that. Then she was searching for the nice graph and she was giving to me. And then we are deciding, okay, let's implement this one because this is gonna look nice and all of that. So that's how at the end, that's the heat map came up.
Okay, that was great. So thank you, Group 1. So I would like
Thank
to
you for providing this opportunity because it allowed us to explore in the IoT domain and to come across with this project. Thank you.
Okay, so I would like to call Karan Vijay